Sometimes we can make a conjecture about some kind of mathematical statement. For example, let's take a look at this one. The product of two odd numbers is a blank. Well, how might we go about making conjecture? Well, we might take a look at just making a whole bunch of examples and seeing if we can build some insight. That's one of the greatest ways to build insight in mathematics and even in other areas, is to look at examples and see what's going on. This is a question which says, let's take a look at the product of two odd numbers. So how about we start off with 1 and multiply it by another odd number, let's say 3. I see the answer is 3. How about we take another odd number, let's say 5, and multiply it by some odd number, let's say 7. I see 35. How about another odd number? Let's take, let's take 11 and multiply it by some odd number, let's say 9. I see 99. Now, what can I conclude about these numbers? When I look at 3, 35, and 99, I notice one thing. None of them are even. So, in fact, they all seem to be odd. So my conjecture is the product of two odd numbers is an odd number. Let me just caution you to notice that that doesn't prove it, but it's a great conjecture looking at this data. Let's take a look at another example. This is a more visual one. The number of circle parts formed by n diameters. Now let's think about that. That's sort of a crazy question. In fact, the first thing I would do seriously is scratch my head and say, So I would immediately draw a picture. It's about something that's visual, so I'm just going to draw a picture, and I honestly don't know what I'm going to do after that. There's a circle, there's the center, and I have to draw a bunch of diameters in. N represents some unknown number of diameters. So let's suppose that I put in 1 diameter. If I put in 1 diameter, how many circle parts do I have? I see 2. If I draw another diameter, how many circle parts do I have? I see 1, 2, 3, 4. If I draw another diameter, how many circle parts do I have? 1, 2, 3, 4, 5, 6. Let's just do one more. So now I have 1, 2, 3, 4. I've got 4 diameters. And how many circle parts? 1, 2, 3, 4, 5, 6, 7, 8. So, when I drew in 1 diameter, I had 2 circle parts. When I put in 2 diameters, I saw 4 circle parts. When I put in 3 diameters, I saw 6. I'm seeing a pattern. It seems like the number of circle parts is double the number of diameters. So my conjecture here would be that the number of circle parts formed by n diameters is equal to 2n. That's my conjecture. Now we still have to prove it if we want to actually call it a true mathematical statement, also known as a theorem. Neat. Making conjectures. Definitely look at examples.